For our third lesson on formula writing, we're going to start adding in our polyatomic ions. When we write formulas with polyatomic ions, you have to know your polyatomic ions. There's no way around this. There is no shortcut. There is no trick. You need to know them. And this is why we've spent so much time since the beginning of the year getting to know them. If you haven't reviewed them, I'd suggest reviewing them. So formula writing with polyatomic ions isn't any more confusing than what we've done. In fact, it's exactly the same. It works exactly the same as we did with the binary ionic compounds. The only thing is now we have to pay more attention to parentheses, because this is going to become important. But the rules that we've learned for formula writing are all the same, so that part is really nice. If we want to write the formula for sodium acetate, we need to break it into two different parts. So we want to look at sodium, which is our Na, and then we need to know what acetate is. If you notice, I keep my polyatomic ions in parentheses. They don't always need parentheses, but it is nice to have them to keep things organized. You can always use them, but you don't always need them. If I look at my charges, I notice that sodium here is a +1, and that acetate's a -1, and so just like we've learned before, I'm just going to put it together. It's actually my favorite polyatomic ion that turns into a compound, because if you read it across, it says nacho. If we look at aluminum sulfate, we're going to again break apart, and I suggest that you guys write these separately like this. So you're going to have aluminum, which will be Al +3, and then sulfate, SO4 -2. Notice that I keep all the polyatomic in the parentheses except for the charges. So my 3 is going to crisscross, and my 2 will crisscross, and I'll end up with Al2 SO4 3. If I had forgotten parentheses, I would have ended up with Al2 SO43. And that's not correct. That would mean I'd have 43 oxygens. So the parentheses are very important in this case. Ammonium phosphate. Here I'm going to put two polyatomics together. Ammonium's our only positive polyatomic ion. So I have NH4 +1 and PO4 -3. Again, I see that my charges are different, so I'm going to crisscross them and bring them down. And I have NH4 3 PO4. I wouldn't necessarily need the parentheses around the PO4, but it's handy to have them there, and it's not wrong to have them there. Calcium sulfate. I have Ca +2 and SO4 -2. Just like we did earlier, the first thing I check is that my charges are the same, so I just put it together to be CaSO4. Now, we can add in our transition metals with polyatomics. So I have copper to nitrate. So I'm going to take copper and have it be +2, and then my nitrate, which is NO3 with a charge of -1. I'll crisscross these and bring them down, and I'll end up with Cu NO3 too. And then finally, I have magnesium acetate. So Mg +2, and then C2H3O2 is a -1. Again, I'm going to crisscross them. Bring them down. And I end up with Mg C2H3O2, and then there's two of them. Again, in this case, parentheses are very important, because I would have Mg C2H3O22, and that would be wrong. And then if we're naming compounds with polyatomic ions, it just works the opposite way. If I have Al2 SO4 3, I just need to break it into its two parts. So I know that Al is aluminum, and SO4 I recognize as sulfate, so I'm just going to call it aluminum sulfate. There's never going to be any mono, di, tri, or any of that stuff that we did with nonmetals with our polyatomic ions. BaOH2. I recognize that Ba is barium and that OH is hydroxide. So I have barium hydroxide. And then I have FeNO3 too. I still can't forget about those transition metal compounds. So Fe is iron, And this one I'm going to have to work backwards. And NO3 is nitrate. So Fe is iron, and then I have NO3, which has a -1 charge. But I have a total of 2 of these. So I must have had this be an Fe plus 2, if I had 2 NO3 -1s to balance it out. In which case, that leaves me with iron 2 nitrate. So I can't forget about those Roman numerals. They don't go away. And then finally, another example of that, I have CuNO2. So I need to know that NO2 is a -1, and if NO2 was a -1, then Cu must have been a +1, and in which case I end up with copper 1 nitrite. Notice how important my endings are? The ites, the ates, okay? Those are going to be very important in distinguishing which is which. Please make sure that you review your polyatomic ions and that you know them very, very well.